Hi, I've enjoyed being your teacher so far, and while you're gone for the weekend, I wanted to send you this video so you can be thinking about teaching your next science lesson. You'll be doing this on your own, but I wanted to walk you through a few things while you plan. With science, we're now using the next generation science standards, and I wanted to walk you through this with the website, explain how these standards really can put a strong impact on our next unit, which is Earth Systems. Remember, in class so far, we've been discussing with our second graders how weather changes and the Earth has to protect itself, and it needs to modify sometimes, and sometimes we need to modify to protect ourselves from the weather, and how all those work together. And I wanted to remind you in that magazine that we read, Science and Children, in that September issue of 2015 on page 8, the authors Warkowski and Willard wrote, I need to read it, it's a long one, research indicates that students will learn best if they engage in multiple practices as they develop their understanding of core ideas and cross-cutting concepts. So keep this in mind when you're forming your lesson plan for this Earth system. You need to make sure there are multiple practices and that the students are doing and find ways to cross-cut into other areas, so they're not getting just one thing, but they're also being able to apply reading and math and several different areas of science. So I'm going to walk you through this so you have an idea of how to use it, and then at home make your own lesson plan, and we'll talk about it on Monday. First, we're going to start. I'm going to click through here and change my screen so you can see the next generation science standards. So right here we have next generation science standards. And we've already walked through this a little bit, so I went ahead and went to Earth Systems in second grade. Up here you always see the title, like we talked about. So next we're going to talk about what's in this box, because all of our standards are in this color-coded box. It looks overwhelming, but once you see it, you're able to really understand it. So the first thing I want to remind you is that also in the article Warkowski and Willard wrote, the NGSS, Next Generation Science Standards, has only two specific purposes beyond its broad vision for science education, namely one, to describe the essential learning goals, and two, to describe how those goals will be assessed at each grade level or band. So keep that in mind. The goal of this is really to help us see what our essential goals are and how these goals are assessed, and the rest is just so that we can plug it all in and use it to our best advantage. Since we've already looked at the top, let's look at this bottom stuff. So in here, we first have our performance expectations. The performance expectations, you can see here, were developed using follow elements from a framework. We've talked about what this was, a framework in K-12, and how that led to NGSS. So this shows us three different things. This is their expectation. Students who demonstrate understanding can compare multiple solutions designed to slow or prevent wind or water from changing the shape of the land. They can also develop a model to represent the shapes and kinds of lands of bodies of water in an area. And they can obtain information to identify where water is found on Earth. So here's what the students are expected to be able to perform. In the red, what we see here is clarification statements. These give us examples and extra clarification, as well as any notes. So this is clarification statement, tells us examples. Right here, assessment boundary, that means students, their assessment does not include quantitative scaling in the models. So when we're making our models and we're assessing them, we do not have to assess on the quantitative scaling, because that part hasn't been taught yet. So these are really important when you're looking through this, to look at specifically the clarifications and the assessment, Now we look down here. In our blue box, we see our science and engineering practices. This box shows us activities that scientists and engineers engage in to either understand the world or solve a problem. So, for example, for Earth systems, that's what we're looking at right here, we see ideas such as develop a model to represent patterns, construct explanations, so construct, design solutions, multiple solutions to a problem. We can say, hey, this area is constantly flooding. How can we solve that problem? And let the students build a model to solve the problem. So these are different practices that we see. Obtain information using various, so they can research different features, menus, icons, etc. That's in your blue box. Over here in our orange box is our DCI, or Disciplinary Core Ideas box. This gives us concepts that we have broad importance within the disciplines, as well as how they are relevant to people's lives. You need this connection and the buy-in from the students. So why on earth are they learning, in this case, about Earth systems and being able to solve these problems? So this explains, we can touch on this, wind and water can change the shape. It shows we can use maps, large-scale systems, plate tectonics. All of this stuff connects into here. For example, if we're going to do multiple solutions to an area that keeps flooding, this would be a great one. There's always more than one possibility. So we can have them compare and test their designs against themselves and each other's and hit on some DCIs. Over here in the green box, this is the cross-cutting concepts box. This box actually has two functions. First, you see up here, these are the cross-cutting concepts that cut across not just one discipline, but all of them. They include things such as patterns, cause and effect. Here it's patterns and stability of change. So we have patterns, which second graders learn about, but also in the natural world. And stability, things may change slowly or rapidly, and this they can see as they test this and work on this, and therefore we're hitting on all of these. In this box is also listed connections to engineering, technology, and applications of science, and connections to nature of science. So this is how it's cross-cutting, not just into other areas, but into other areas of science. Now, at the bottom of here, you also see connections to other DCIs. So we have other connections. Here's one connection here we can look up. This is across different grade levels. This touches into different grade levels. And down here, a lot of the lessons and things that you're working on up here also cut into Common Core standards, which are listed here. And these are Common Core standards for literacy and for mathematics. So these are important to kind of look and see if we can cut on any. Maybe they're reading and writing numbers using base 10 as they work on their model and compare and contrast. And while they're doing that, they're maybe going to record it and add drawings or visual displays. Therefore, they're cutting this Common Core standard and this one all at once. We're using the most of our time, and they're soaking up the most. The other thing when you're looking on this that I wanted to pop out is over here, you can look at it just in black and white. If you want to just look at what the practices and the core ideas are, you click on this and you see the blue matches here, the orange matches here, and if you want cross-cutting, you can do this, and you have these right here. So that's just a few things I wanted to point out to you. Now you're properly, let me put myself back on here. So now you're properly armed to use that site and plan a great lesson. Don't forget, I'm going to read another quote to you to remind you. When we read in that chapter book, Framing Science and Science Education on page 9, those authors state, learning to think scientifically and to understand the scientific view of the natural world takes time. Science experiences from the earliest grades are essential for helping students to learn to think and understand. So it's going to take time. It's going to take you time, it's going to take me time, but most importantly, it's going to take the students time to wrap around all these concepts and come to it. But the more they do, and the more science experiments they do, the more they will think harder, think outside the box, think of multiple solutions, and the more they will understand. So good luck in your lesson planning. Let's get this class to think and understand about science. Have a good weekend.